All right, this is going to be kind of a weird one tonight that I'm doing. It says in the book that there's a seagull that keeps dropping a clam against rocks. He drops it 25 meters, and that's in order to crack it open. All right, well, let's do, the book says, how long is it going to take the clam to hit the ground? Well, it's 25 meters. Let's do this quickly. 25 meters is the distance. I want to know time. We just did a problem like this. So time equals vertical, remember vertical, based on G, okay? Ty from a zero, from an initial velocity of 0, this is right? Isn't that right? Okay. And I also, you have two equations. At V naught equals 0, these two equations work. V naught is 0 though. That's important. Okay, so we have, it's going to be 25 meters. So it's going to be Ty equals 25 over 5. Easy. So the square root of 5. Square root of 5. Okay, let's see what that is. Square root of 5. Turn it on. Clear. Square root of 5 equals 2.24 seconds. 2.24 seconds. So this is going to be 2.24 seconds. Okay? That's the first one. All right? This looks a little sloppy. All right, let's see if we can make this a little neater. Okay? So I'm going to erase this. Okay? I'm going to erase this. Okay? So this is going to be 2.24 seconds. Okay? That's how long it's going to take to hit the ground. Okay? Now, let's say we have distance and we want to find final velocity. Well, I know that final velocity equals initial velocity plus 2AD. A is 10. That's 0 because it's falling from rest. Okay? So this is going to be equal to 2AD. VF equals 2 times 10 times 25. 2 times 10 times 25 is 500. 2 times 10 is 20. Times 25 is 500. So what's root? Root 500. Root 500. 22.4. 22.4. So the velocity equals 22.4 meters per second. That's pretty fast, actually. 50 miles an hour, 48. Okay? So I'm going to write that in. Okay? So 22.4. Got it? So 22.4. This is 22.4 meters per second. Now, I want to know what the momentum is. I know that momentum equals mass times velocity, right? So what is 0.1 times 22.4? 0.1 times 21.4. Do you need a calculator? Let's use a calculator. Let's try to predict what it's going to be. What do you think it's going to be? Okay, so 22.4 times 0.1. Okay, you getting this yet? Yep. Mental math. 2.24, and that's going to be kilogram meters per second. Okay. Now I'm going to say that I'm going to say that the time in which it stops, is going to be 0.001. Now, we're not going to say it bounces, even though it does, and adds to impulse, etc. We're just going to say, boom, 0.001 seconds. That's instantaneous, okay? So this is going to be 2.24 is going to be the change in momentum, because that's what it's going to have right before it hits the ground, and then it's going to have none. So it's going to change 2.24. We're assuming not bouncing, that it's just going to go boom, okay? It's not going to do that. It's going to bounce, which makes the momentum changes even greater, but we'll ignore that. This will be a minimum value. 0.001 is instantaneous, okay? So this is going to be 2.24. That's the change in momentum, and I know that's going to equal Ft. So I want to know what's the force that's being exerted on this clam. So that's going to be F times 0.001. And what is 2.24 divided by 0.001? And that's going to be 2,240. I weigh 1,000 newtons. I don't weigh more than 1,000 newtons. If anything, I weigh less than that. So that's 2 of me plus another quarter. That's a lot. And this seagull has to keep dropping it. So those shells are very powerful. So what we did was we took a simple problem where they just wanted to know how much time it took to get down, and we did all kinds of things with it. We came up with the time was the original problem. We came up with final velocity. We came up with momentum. We came up with force. We did a lot of good things, okay? Look the problem over, very important, and good night.